Section 8.4, Math 96. How to solve three equations and three variables. We practice on two equations and two variables, x and y. Now we are dealing with three equations and three variables, x, y, and z. So one of the best way to do this type of equation is use method of eliminations. So what I do is I number my equations, number 1, number 2, and number 3. Then you select a pair of equations. Like, since 1 is easy one, yeah, it doesn't have that many coefficients for x, y, z, I'll pick that, and number 3. Between 1 and 3, I try to eliminate x. You're allowed to eliminate any of these variables, but I see x is easier because these two are already equal and opposite. So I take equation number 1 and equation number 3, put next to each other, and x is eliminated. And I also take equation 2 and 3. And 2 and 3, I try to eliminate x. So in that case, I want this minus x to be minus 2x so I can cancel. So I multiply everything by 2. So the first one, when I eliminated x, I see equation with no x in it. And the second one, when I eliminate x, I end up having equation which also does not have any x in it. And if you see all the numbers are divisible by 2, you do that to make the problem simpler to do. So now I have one equation with y and z, and I have another equation with y and z. See, I simplified this one too because all three numbers are divisible by 2. All right. So then I take these two equations. These two equations, they have y and z. They don't have any x. I'll put these together. And then, so remember, we pick two pair of equations. 1 and 3, eliminate x. 2 and 3, and eliminate x again. Then you end up two equations with y and z only. You put this together, now is solving two equations and two variables. In that case, I decide to eliminate z because I have minus 2z. So I want to change this to positive 2z. I multiply by negative 2. Remember, when you multiply by negative, you make sure you multiply by all the numbers and the terms, not just for what you have on this side. You also have to multiply by what you have on that side too. So in that case, you find value of y. Minus 2 times 4 is minus 8. Minus 2 times minus z is positive 2. Minus 2 times minus 48. Z cancel, you find a y. Now, when you find a y, then you could pick one of these two equations. It doesn't matter which one to find your other variable of z. So in that case, I use these equations. I take negative 5 and substitute for the y here. Solve this, it gives me the second value, z equal 4. Now you have z and y value. Then the original equation was x plus y plus z equal 1. You substitute here to find your last variable, which is x. And when you write the final answer, x always has to be first, and then y, and then the z value. Number 2 also is another three equation, three variables. See, for that one, again, first I label all the equation, number 1, number 2, number 3. Then you take 2 pairs. So here, I'll take 1 and 3. So you have a choice. You could take any 2 equation as 1 pair. 1 and 3. Now, you need to decide which variable is easier to eliminate. It sounds like z is easier to eliminate because all I need to do is I want to make sure this is minus 3z. To make this minus 3z so you can cancel with 3z, I multiply everything by minus 3. Again, remember, when you multiply by -3 will distribute. Multiply by 5, multiply by 3, z, and also multiply by -9. Minus 3 times minus 9. So you should multiply by everything. So in that case, you end up having this. 3z and minus 3z cancel. Again, you have one equation with one variable. Since they all are negative, I multiply by negative to make it positive. It's easier. This is one equation that has no z on it. Then I need to take another pair and eliminate z on that one too. So you go to 1 and 2. And 1 and 2, I want this to be minus 2z, so I can cancel. So you do all this, and then you come up with another equation, which is x and y no z. And then since they all are divisible by 9, 9 divided by 9 is 1, 9 divided by 9 is 1, and 0 divided by any number is always 0. So this is one equation. The second equation was this. I'll put this together and multiply the top by negative so it can cancel. So that gives me the value of y. When you have y, you could find the other numbers by substituting into equations. The third equations, again, very similar. You have 3 equations and 2 variables. I labeled the equations. I'll take 1 and 2. Now, I decide to eliminate x. Again, it's your choice. It doesn't matter which variable you cancel. We all end up same answers. So I want to eliminate x. This is 4x. I want this to make this minus 4x. So multiply everything by -4. Cancel. It's interesting because in this one, when you multiply, 2 variables cancel automatically. So what it is just y. Y is 0. You find a y. Because here is 1y equals 0, so y is 0. Now, since y is 0, now I'll go ahead and take 1 and 3. 1 and 3, they give you y equal -1. Something is strange because one pair tell you y is 0, the other pair is y is -1. So that means there is no solution to this problem. You cannot have 2 different numbers for the y value. So there is no solution to this one. I want to show you something here. You know, when you have two lines intersect at one point, so you have one point of intersection because it's in 2 dimensions. These are 2 equations, the intersect is here. But when there are 3 lines, it has to be in the plane because you cannot draw 3 lines on a page that shows the point of intersections. So if 3 lines intersect at a point, at one point, then we say system is consistent and has one solution. If three lines are all parallel lines, then there are infinite number of solutions. It means that if they coincide, it means they all are the same. Then there are so many places they touch. If the lines are parallel lines, not this one, I'm sorry. If the lines are parallel lines, then there is no solution. So in either of these cases, you don't have any solution, infinite solution, and one solution. So when you solve three equations and three variables, you have one of these three options. One point of intersections, many points, all three lines are almost the same, they touch each other, many points, or they don't intersect because they all are parallel lines, so no solutions. So that's the case for solving linear system. So this is a case that there is no solution. On number 4, same thing. We pick, we label numbers, then we take 1 and 2, we eliminate x, then we take 2 and 3, and we eliminate x. Now I have two equations. If you notice, both equations happen to be identical. The system is dependent because you come up with the same equations. Which is this case. Infinite number of solutions when you have the same equation. So no solution in this one, many solution, infinite numbers on this one. Some other equations, they all are very similar. So like in this one, we take 1 and 2, eliminate z. Then I take 1 and 3, eliminate z again. Then I'll take these two because they don't have any z in it. You solve it, they give you the value of x. When you find the value of x, then you take this and substitute in one of this equation to find your y. You have x and y. Then take one of these three equations, which I picked the first one, and find the z value. So we are using method of eliminations for three equations and three variables on this problem. Another one. Again, you label 1, 2, 3. You take 2 and 3. So that gives you this. Now, when you have this equation, remember in these problems, the first equation doesn't have any y value in it. So I'll take this one and the other one, which I eliminate y, put these together and solve it to find the x value. So remember, first you take 2 and 3, multiply by 3, so y cancel. So you end up one equation which has x and z in it. And we take another one, x and z from the top, put these together, solve it, they give you find the x. You have the x, you have the z, you have the y, that would be the final number.